Hello, we're in Chapter 5, Section 6, working on the quadratic formula. I'm doing the guided practice problems on page 361. If you're following along on the PDF, that's actually PDF page 52. And we're going to do problems 2, 3, 4, 5, 6, 7. All of the problems in this section are going to have real zeros. In the next video, those are going to have zeros that have imaginary components. So for these are the problems that I would get in my Algebra 1 class, for example. Look at how I work each problem. This is what I want you to show me on your homework and on the assessments. Both Corbett and I have been working on this for a while, and I think both of us agree that this is probably the best way to do this, even if your Algebra 1 teacher showed you something a little bit different. All right, so let's get started. So the first thing I'm going to do is I'm going to set the function equal to 0. I'm finding the 0, so I need to find out where does f of x actually equal 0. So you're going to see that every time, and you need to show me that on the homework and the assessments. Next, oh, and by the way, this one, if I said just find the 0 and that was it, find the 0 of each function, do not use quadratic formula for this. What two numbers multiply to give 10 but add to give 7? That's x plus 5 and x plus 2. So I'm going to end up getting -5 and -2. You can do the factoring in your head, but I got to follow the directions. So I'm going to use the quadratic formula. Hopefully I get the same thing. If not, bad things are going to happen. Let's identify the parameters. A equals 1, B equals 7, and C equals 10. Discriminant, b to the second power minus 4ac. This is 7 to the second power. Subtract 4 times 1 times 10. 49 subtract 40 equals 9. Why is that nice? Because 9 is a perfect square. And in one of my next steps, I'm going to take the square root of it. The quadratic formula is -b plus or minus the square root of b to the second power subtract 4ac divided by 2a. b is 7, so I get -7. The discriminant is 9, so I'm going to take the square root of 9. I know what that is. 2 times a is 2 times 1. All right, opposite square root multiply. So I get -7 plus or minus 3 divided by 2. Do not stop right here. Since I took the square root of 9 and got 3, I don't have a radical anymore. Now I can keep working. So I get x equals -7 plus 3 divided by 2. -7 plus 3 is -4. -4 divided by 2 is -2. Huh, that sounds familiar. Or x equals -7 subtract 3 divided by 2. -7 subtract 3 is -10. -10 divided by 2 is -5, which is exactly what I said it would be when I did it by factoring in my head. Let me move that up so you can see it. All right. So don't stop there. Keep working it until you get the most simplified form of the solution. Don't forget that the plus or minus, that means I get 2 solutions, or in this case, 2 zeros. One with a plus sign, one with a minus sign. Let's do the next one. Set it equal to 0. 3x squared subtract 4x minus 1. My parameters, a equals 3, b equals -4, c equals -1. Discriminant. b is -4, so I get -4 squared. a is 3, c is -1. -4 times -4 is positive 16. 4 times 3 is 12. A negative times negative is a positive, so this is going to be plus 12, which gives me 28. My quadratic formula, well, it's not mine, it belongs to all of us. Negative b plus or minus the square root of b squared minus 4ac divided by 2a. Negative b is the opposite of negative 4. Square root of the discriminant, which is 28, which I found. I just put it under the radical. And 2 times a is 2 times 3. Opposite, simplify, multiply. And then we'll see if we can go further than that. Opposite of negative 4 is 4. Square root of 28. 28 is 4 times 7. So I get the square root of 4, which is 2, times the square root of 7. And 2 times 3 equals 6. Now, so many students are going to stop right here. Because they're going to be like, oh, nothing I can do. Look at that. That's 2 times 2. That's 2 times square root of 7, and that's 2 times 3. I have a common factor of 2 all over the place here. So I could write it like this. 4 over 6 plus or minus 2 times the square root of 7 over 6. Simplify. Reduce. I get x equals 2/3 plus or minus square root of 7 over 3. I could, and I'm going to put it over here in the corner. I could have also kept this together and just said 2 plus or minus square root of 7 over 3. All right, number 4. Well, this one's an odd one for number 4. An odd in the weird, not odd number. Set it equals 0. And check this out. What's my last part, my last term? I want to put the 0 in there so I know what it is. My parameters, a equals 3, b equals negative 5, c equals 0. Let's take care of that discriminant first. B squared minus 4ac. So I get negative 5, subtract 4 times 3 times 0. Well, that's kind of cool. Oops, squared. Sorry, forgot the exponent. I get 25 subtract 0, which is just 25. Da, da, da. Quadratic formula. X equals negative b plus or minus b squared minus 4ac all over 2a. I get x equals negative b, which is the opposite of negative 5, plus or minus the square root of 25 all over 2 times 3. Excuse me. Opposite, simplify, multiply. Opposite of negative 5 is 5. Square root of 25 is also 5. 2 times 3 equals 6. Now, since my radical, poof, went away, because the square root of 25, I know what that is, I can keep simplifying this. So I get 5 plus 5 divided by 6. That's 10 over 6, but I should reduce it to 5/3. My other one is 5, should write, oops, sorry, x equals 5 subtract 5 divided by 6, and that's just 0. By the way, this one I could have done by factoring, because I didn't have that last term here. I could have just factored out a common factor. This is x times 3x minus 5. And that's the x gives me the 0, and the 3x minus 5 gives me 5/3. Number 5. Set it equal to 0. All right. Let's talk a little bit about the negative in front of the x squared. Absolutely nothing is going to be different if you do a equals negative 1. Nothing. You'll be fine. However, there's a however, sometimes that causes stress for people. So one thing I can do is I can multiply everything by negative 1. And when I say everything, I mean the left side and the right side, everything on the right side. Multiplying the left side by negative 1 just leaves me 0. So I could do this. Negative 1 times negative x squared is positive x squared. Negative 1 times negative 5 is positive 5x. And negative 1 times positive 6 is negative 6. Excuse me. Either way, I'm going to get the same thing. And if I look at this part, let's first do that. A equals 1, B equals 5, C equals negative 6. Check this out. When I do the discriminant, take the B and square it. Well, 5 or negative 5 is going to give me 25 either way. But what about this part? Well, if this is negative and that's positive, so I got negative times positive is negative, and then that negative gives me another positive. Or that's positive, that's negative, I still get positive times negative is negative. So I'm going to end up with the same discriminant no matter what. I'm going to do 5 to the second power, subtract 4 times 1 times negative 6. I get 25 plus 24, because negative 4 times 1 times negative 6 is positive 24. And that gives me 49. 49 is nice. I wonder if I could have solved this by factoring. My quadratic formula, negative b plus or minus the square root of b squared minus 4ac divided by 2a. I get the opposite of b, which is the opposite of 5, plus or minus the square root of the 49 that I just figured out over there, all over 2 times 1. Opposite, simplify, multiply. So I get negative 5 plus or minus 7 over 2. I can split this like I did over here. I get x equals negative 5 plus 7 divided by 2. Negative 5 plus 7 is 2. 2 divided by 2 equals 1. So I get x equals 1. The other root, or 0, because we're dealing with functions, is negative 5 minus 7 divided by 2. Negative 5 subtract 7 is negative 12, and negative 12 divided by 2 is negative 6. I could have they could have found the zeros of this by factoring. I would have got x subtract 1 and x plus 6. And of course that would have given me positive 1 and negative 6. Now you're probably wondering, well, if I can do it by factoring, why don't I? That's because the directions tell you clearly use the quadratic formula. Alright, 0 equals 4x squared subtract 5x subtract 6. I don't know if I can factor this one. My a is 4, my b is negative 5, and my c is negative 6. Let's find the discriminant. Excuse me. So I get negative 5 squared subtract 4 times negative 6. Negative 5 to the second power is 25. A negative times negative is going to be positive. And let's see, 4 times 4 is 16. 16 times 6 is 60 plus 36, which is 96. And when I add these together, I do believe I get 121. Nice. Why is that nice? Because that's a perfect square. Quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. My b is negative 5, so I got the opposite of negative 5. Plus or minus the square root of 121 divided by 2 times 4. Opposite, simplify, multiply. The opposite of negative 5 is 5. Square root of 121 is 11. And 2 times 4 equals 8. So I get x equals 5 plus 11 divided by 8. 5 plus 11 is 16. 16 divided by 8 equals 2. Or x equals 5 subtract 11 divided by 8. 5 subtract 11 is negative 6, and negative 6 divided by 8 is negative 3/4. So it looks like I might have been able to done that one by factoring. Usually you could have done it by factoring if you end up with a perfect square here. I'm trying to think of when that wouldn't happen, but hey, okay. All right, last one, number 7 for this video. I get 2x squared, and I'm going to put this missing term in there, 0 times x, subtract 19, because I don't want you to think that that's the b. All right, I don't want you to go a, b. All right, so know that it's 0 times x. So a equals 2, b equals 0, and c equals negative 19. So I get 0 squared minus 4 times 2 times negative 19. Yikes. 0 squared is 0. Negative times negative is a positive. And 8 times 19 is 80 plus 72, which is 152. So I get 152. I want to double check that. 4 times 2 times 19. Yeah, okay. Quadratic formula, one more time, is the opposite of b, plus or minus the square root of the discriminant. I didn't give myself enough room here. All over 2a. So I get the opposite of b, which is 0, plus or minus the square root of 152. Divided by 2 times 2. Opposite of 0 is just 0. 0 plus anything, the 0 is not going to show up. So I get the square root of 152. All right, let's think about this. Let's take 152 and divide it by 4. Aha, that's 38. That's good. All right. 152 divided by 9. That's not going to work out. 152 divided by 16, that's not going to work. And I know 152 divided by 25 is not going to work, so it's going to be 4 times 38. So that gives me, square root of 4 is 2. 38 I know is 2 times 19, and both those are prime, so I'm not going to be able to get a perfect square out of that. 2 times 2 is 4. And don't forget, I get two answers. One's plus, one's negative. So I get plus or minus square root of 38 divided by 2. Excuse me. All right, we'll see you in the next video.